Advanced Algebra Chapter 7, Lesson 7, and we want to look at inverse relations and inverse functions. We'll begin by looking at inverse functions, how we determine what those are, how do we determine the inverse function, how do we determine the domain and range of inverse functions, and then what happens when we compose a function with its inverse. Now, let's take a look at inverse functions first. If the relation's elements A of its domain to element B of its range, then the inverse relation pairs B with A. So if AB is an ordered pair of a relation, then BA is an ordered pair of its inverse. And simply all that means is this entire lesson comes down to one concept, and then everything else is just an application of that. And here's the concept. Within inverse relations, all of the x values become the new y values, or are the y values of the inverse. And all of the y values of the function become the x values. So in inverse relations is simply a matter of switching the domain values with the range values and vice versa. So all of the members of the domain are now members of the range in the inverse. And all of the members of the range are now the domain of its inverse. So we're simply swapping x for y and y for x. Now, there's some new notation that we want to look at. The inverse function notation is this f negative 1. And now, this is not f to the negative first power. And in fact, we seldom see this written as a negative 1 power. This is almost always in mathematics represents the inverse. So we read this as the inverse of f, or f inverse. The notation f of x is used for functions. The relation f inverse may or may not be a function. And what that means is, even though the original function we're looking at, let's say x squared, that's a function, passes the vertical line test. The inverse of that is not a function. It does not pass the vertical line test, and you'll see that later. So a couple of things I want you to understand from our discussion so far. Inverses are simply x's becoming y's, y's becoming x. The notation is f negative 1, and we read that as f inverse. And that the inverse of a function is not always a function. So sometimes you can have a function and its inverse not a function. Now they can both be functions, but not always the case. So wrapping that up, an inverse relation then simply is where both an x and y values switch places. The domain of the function becomes the range of the inverse, and the range of the function becomes the domain of the inverse. So it's very important that we know how to determine domain and range, and then we're going to simply switch them. So in a mapping diagram like this, you have these domain values and then these range values. The inverse of this relation, these range values become the domain, and these domain values become the range. We're going to denote the inverse with this function notation f inverse, and this may or may not be a function, but it's very important, very, very, very important, that if you're talking about an inverse, that you indicate it with this notation, because that's going to affect how we view the domain and range of the functions when we go to determine those. I'll talk more about those later, but make sure you understand that if we're talking about an inverse, you must use inverse notation to make it clear to the person who's reading your work that you are talking about the inverse of a function. Now, let's talk quickly, how do we determine the inverse of a function? Well, we can do it three different ways: by looking at a table, algebraically, and graphically, and then we want to know, is the inverse a function? We'll cover a table and algebraically very quickly. Now, if we understand what an inverse is, an inverse relation is where we simply switch the x values with the y values. So if I'm given a table, and these are my x values, and then these are my y values, the inverse relation will simply be swapping the position of each of these values. So this x value of 1 is going to be the y value of the inverse, and this y value of negative 1 is going to be the x value of the inverse. So the inverse relation simply switches the x values with the y values. Okay, that's pretty simple. And again, that's the lesson. X becomes y, y becomes x. Everything that we do now is just an application of that principle. So simply apply that to this table. How would we determine the inverse algebraically then? Well, again, applying the same principle. The x becomes y and the y becomes x. So if this is the algebraic expression of a function, to find its inverse, I simply switch the x value with the y and the y with the x. So the y is going to become x and the x is going to become y. Now all of our functions are solved with the y value, or solved for the y value. So after I switch them, it's just simply an algebraic exercise in solving for y. So I'm going to subtract 3 from both sides and then take the square root, and so this would be the inverse of this function here. So the inverse of x squared plus 3 is plus or minus the square root of x minus 3. Again, one principle applied, different situation. X becomes y, y becomes x. One additional question that we want to answer is the original relation a function, and then is its inverse also a function? If we look at this expression here, is this a representation of a function? And yes, it is, because for each x value that I put in, if I evaluate it, I'm only going to get one y value. So because one x value goes in and one y value comes out, this is an inverse, or this is a function. If this is the inverse, is this a function? Well, this would not be a function, because you'll notice if I put in one x value, what do I get? I get plus or minus the square root of this value. So whenever I see a plus or minus in front, if the inverse has this plus or minus, that means you're going to produce two y values for each x value that you put in. Y is equal to either the positive of this or the negative of this. So whenever you have a plus or minus in front of the expression, that expression is not a function. So when you solve these and when you're asked that question, the only thing you have to look for is a plus or minus. And if you have a plus or minus, it is not a function. All other scenarios will be a function for what we're dealing with right now. So let's do a couple of examples here. Here's the expression y equals 3x plus 1. So to determine the inverse function, the y is going to become an x, and the x is going to become a y, and then I'm going to solve for y. So I'm going to subtract 1 from both sides, and then I'm going to divide by 3. So y is equal to x minus 1 divided by 3. This is the inverse. Now notice I want you to use this notation, and x minus 1 is 3. Now is this a function? Because there is no plus or minus associated with it, this will give me one y value for each x values, so this is a function. Another example, here we have the expression y is equal to 2x minus 1. To determine the inverse, the y becomes an x, the x becomes a y, and we solve for y. So we're going to add 1 to both sides, and then we're going to divide by 2. Because there is no plus or minus, this is also a function. So here we have our example, y is equal to 5x minus 2x squared. To determine the inverse, the y becomes an x, and this x becomes a y, and then we're going to solve for y. So to make this positive, I'm going to move it to this side here, and that means I'm going to move the x over here, so this is going to be 5 minus x. And then I'm going to divide by 2. Y is equal to 5 minus x divided by 2. And then to solve for y, I'm going to have to unsquare this, so I'm going to take the square root. Because I'm taking the square root, this is going to be plus or minus 5 minus x over 2, and then I could rationalize the denominator. So this is going to be the square root of 5 minus x over the square root of 2, multiplying the square root of 2 times both. So this is going to give me then 10 minus 2x, and then over 2, plus or minus. Now, is this a function? Because there's a plus or minus, that means when I put in an x value, I'm going to get a positive y value and a negative y value. Therefore, because I'm producing two y values with each x value, this is not a function. Okay, so to sum up very quickly, the entire lesson is built upon one principle, that in an inverse, the x values become the y values and the y values become the x values. everything that we do then is simply an application of that, whether it be in a table, we just switch the x's and the y's, or whether it be in an algebraic expression, we switch the x's and the y's and then solve for y. And then the inverse will be a function as long as it does not produce two y values with each x value. So I'm looking for plus or minus. As long as I do not see a plus or minus, then the inverse will be a function. If there is a plus or minus, and that's only going to be produced when I have to take the square root when solving for y, then that inverse is not going to be a function.